A worker comes upon a little boy with a dark complexion floating naked and limbless in London's River Thames. The investigators immediately start looking for the boy's identity and place of origin. One of the investigators is acquainted with a professor whose work focuses on the global distribution of strontium in soils. He thinks they might be able to pinpoint the boy's origin by using the professor's database on the world's strontium concentrations. They focus their search on a specific area in Nigeria by using analytical chemistry in conjunction with detective work. They then gathered samples of the boy's bone material and samples of strontium-doped bone from the site and were able to measure their strontium concentrations. The detectives then used the information to create a plan to identify the ones responsible for the boy's murder.
Before comparison to the database of global strontium concentration, the strontium to calcium ratio present in the boy's body was first identified using inductively coupled plasma atomic emission spectroscopy. It revealed that the strontium and calcium lines are 370 and 421 nanometers, being relatively free from spectral interference, exhibiting dramatically different sensitivities, which allows the simultaneous determination of both calcium and strontium. Given this, investigators discovered a 50 by 100 mile land between Benin City and Ibadan in Nigeria that matches the strontium level from the boy's bones. A search was then conducted within this area and locals were made aware of the details of the case to ask for their assistance in obtaining information about any young boy who had recently gone missing. This led to the identification of a woman who had taken her 7-year-old son to London just prior to the boy's murder and returned without her son. Another analysis strengthens the claim that the missing boy is the body found floating on the river, as pollens found in the boy's stomach indicated that he had been in London only for a short time.
In order to solve difficult criminal cases, forensic analytical chemistry seeks to utilize new evolving techniques in the lab or on the scene. The object of the analysis is crime evidence, which can be a material that has been seized or a biological sample. There are frequently only little amounts of samples that contain trace amounts of the analyte. For example, the FBI uses spectrophotometry being the standard of forensic examination. For distinguishing between two samples that are essentially indistinguishable, spectrophotometric analysis is required. The majority of forensic analysts analyze inks and fibers using UV-vis spectroscopy, and they use thin-layer chromatography as a secondary technique. Trace evidence such as hairs, fibers, and glass can be quickly and accurately evaluated using spectroscopy. Inks found at the scene can be identified by their distinctive hues using a wavelength analysis. This technique is a non-destructive and safer alternative than chromatography. As a result, spectroscopic analysis is the ideal choice for forensic examination.